Evaluate and communicate the impact of environmental variables on population size.
Hey guys, we're here with the science teachers and a special guest today. We're going to talk to you about LS2.1.
Biotic, living once living or a part of something once living. Example, dead squirrel, tree, humans.
Another example of this could be like hair or a deer antler, or if you clipped your toenails, gross, but still biotic.
Abiotic, non-living and never was living. Example, water, sunlight, air, rocks.
Also make sure that when you are reading about things that are biotic or abiotic, that you pay close attention to whether it is using the letter A as in I am a biotic thing, or if we are looking for abiotic things.
All right, so we're going to go from big to little. So we're starting at the bottom and going to work our way to the top to individual. So the first one we're going to talk about is biosphere. And biosphere, remember, bio means life. And sphere is just a 3D circle. So it's what do we know that's got life on it and is in the shape of a 3D circle? Well, that's the Earth. So when we talk about biosphere, we're talking about the Earth.
All right, our next level is a biome. This is an area on Earth that has a specific climate, specific features, specific abiotic and biotic factors. You're going to have different ecosystems within a biome. And we're going to look at biomes in a different standard specifically.
Okay, our next level is going to be ecosystem. An ecosystem is a specific area, and it's all the living and non-living things that are in that area. So you've got different populations of species. I've got fish, I've got jellyfish, I've got grass, everything that is biotic, and then also the abiotic factors like rocks and water.
All right, we're stepping down smaller. Now we're going to look at a community. This time when we look at a community, we're looking at just the biotic factors, but we're looking at all the biotic populations. So we're looking at all the jellyfish, all the fish, all the grass, all the crab.
Population, how much of a certain species is in an area?
And then our smallest level is an individual. It's one. You are an individual. That fish is an individual. One tiny bacteria, that's an individual. So we're talking about one specific thing that is an organism. So one specific organism, but that one individual, like you could name it.
Carrying capacity.
And limiting factors. Limiting factors, a resource that is scarce and it limits the size of a population. Example, food, water, shelter, space. Another example, water in a desert and food in Antarctica.
So carrying capacity is the largest size a population can get in a certain area because of limiting factors. So we can only have so many jellyfish because there's only so much space in a particular region of the ocean. And there's only so much food in that area that those jellyfish can eat. And then there's some organisms that need sunlight. So only so many plants can grow there, only so many producers because they have to get the sunlight.
All right, so our carrying capacity graph, you should be able to spot this from a mile away because it looks really specific. You can see down here at the bottom that our time is 0 and our number of individuals is 0. And then as it starts to climb, it's going up and up and up until it hits where the carrying capacity is. It usually goes over the carrying capacity just a little bit, and then you've run out of your limiting factors. You've gotten low on food or water or space, and the population begins to drop. The population usually drops a little bit below the carrying capacity, and then it'll start to climb again because we've got some of those, a little bit more food and a little bit more water. And it goes up, and you'll see it does this cute little wavy thing until it basically balances out right at carrying capacity. That is where the ideal level for a specific species in a specific area because of the amount of food or water or space that is available. Let's talk through it. Look at the graph. Let's look at the deer first. Okay, the deer population goes from 30 all the way up here to 70 something. So what happens when the deer population goes really high? What happens to those resources?
They decline.
They decline, right? So they've gone way, way down. So then in the next year, you can see our deer drop down really, really low. Why did they drop down really low?
There's not much food to eat.
Yeah, because our resources have gotten a lot lower. So it had to balance out. Now, my deer start to climb. What happens here in year 4 that changes how much my deer can go up? Because you see that they don't climb quite as high as they did before.
Predators were introduced into the ecosystem.
Good. So my predators were introduced. It kept my population of deer from going up as high as it was. It also kept what happened to the resources when
They
my
sort of
wolves.
leveled out.
They sort of leveled out too. And look at my populations just sort of hang out right there in the middle.
Yeah. So you could talk about, well, if there were no predators in an ecosystem, what would happen? What would be
the deer
happening?
would become pests.
Okay. And then, so how necessary are predators in the ecosystem?
Very.
And what would happen if there weren't predators and our deer population just totally wiped out some of those limiting factors, like if they ate all of the plants that were necessary?
It would be up to the humans or another predator to solve it.
Or what would happen to the deer population?
It'll
They eat all the grass, right?
Yeah. Then
Then
it'll
what?
decline again.
Yeah.
Extremely till the grass goes back.
Awesome. All right, that sounds like a great explanation of this graph. Remember, you have a quiz on Monday. If you have questions, you need to come and see your science teacher first thing Monday morning or at the very beginning of class. Have a great weekend. We'll see you on Monday.